Hi, this is Karen O'Brien, and I wanted to do a shorter video for floodplain cross-section methods. All right, so floodplain cross-section is designed to pick a group of cells that water will flow across or past, and use those to collect the discharge. So the way that you set this up is using a floodplain cross-section. You can see that our editor is right here, and it has changed since my last video, so I want to go ahead and update this video a little bit. Before you get your floodplain cross sections, you want to do kind of a short run, like I would say like a 2 or 3 hour rainfall event. So you don't have to run a full model and get some general flow directions for your model. And then you can use these flow directions to build floodplain cross sections. So I'm just going to go in here to a place that has a lot of flow flowing past it. You can see I have a floodplain cross section right here. And we can go ahead and put one in right here. So if I click a floodplain cross section, I'm going to click that. That will turn the editor on, and then we can digitize our cross section. And in this case, I am using these arrows to help guide me. So if I wanted to put one at the end of this cul-de-sac, I would put it like this. And if I wanted to put one here, so say I want to do some kind of detention or something, or accumulate the flow and see what's crossing this line right here, I'll put it right here. So I'll go left click, right click, and then click the button again, and it will fill in the cross section, and it will set the potential flow directions. All right. Now, if you can see that we have two potential flow directions for a cross section that is vertical line, vertical to your map. All right. And that will be either east or west. Now, obviously, from our velocity vectors, our flow is predominantly flowing to the west. And then you can pick up that direction and then hit, I'm going to turn that off, and then hit the schematize button. And then let's also clear that rubber band. Okay, now what you see here is that I got a little too close to the edge of that. So I want to edit and back that off just a little bit. So let me back that one off. And then I will save and schematize that one more time. In that, you can see that links my floodplain cross section to just these two lines. Okay, here is your user line. That's how you locate or place your cross sections. And this is your schema data, where we have both the linking system of the floodplain cross section and the individual cells listed in this system. And those will be saved to a file called fpxec.dat. Now, let's go ahead and take a look at some of these other ones that I've made. Let's go ahead and hit the I, and then we'll select cross section number 1. And you can see that all of the flow is crossing that. It's important that these vectors cross this, and it's important that these do not touch any other floodplain cross section, okay? Here's the rule. A grid element can only be listed once in the FPXSec data file. All right, so do not touch them and do not cross them. This one, you can see if I were to move this one south by 1 grid element, that would be an invalid cross section because the flow is not crossing the line. It would then be parallel to the line. So that's rule number 2. The flow must cross the line. It doesn't have to cross perfectly perpendicular to the line, but it must cross the line. Now, what's happening when you run this floodplain cross section is that each of these 3 cells are going to accumulate all of the flow that crosses this path. So this cell can connect to this neighbor and this neighbor. So these two neighbors can feed this cell, and it will store all of that discharge in a table. And then this cross section can be given water from this direction and this direction and this direction, and it will accumulate all of its flow. And then this one can take water from here, here, and here, and it will also account for all of its water. And at the end, all of that will be summed up into a single discharge for this cross section. Let's go ahead and continue on and look at some of the other ones. Okay, you can see that if you have one that is diagonal to the flow, it will also, in addition to getting the flow from these guys, it will also account for the flow that crosses down the center of that two grid cells that are not exactly connected to one of those grid elements. It still accounts for that flow. And if it is diagonal like this, you can see here that your only two options are flow against the cross section. If you accidentally selected the wrong value, the reported flow would be a negative value. It would be a negative discharge, a negative velocity, and that's how it would be reported. You can see that that one is set up correctly. That one is okay. That one is set up correctly. Then now, as you can see here, we're going from cross section 5 to cross section 7. That might be a bit of a problem, I just recognize. So we'll take a look at that in a second, but you can see that all three of these arrows, if we close that off, all three of those arrows are crossing that line. But where I did not extend it here, and I did not extend it here because those arrows are not crossing that line. And then number 8, you can see that they're all crossing the line. And then number 9. Oh, and how did I make these velocity vectors? Sorry, I forgot to show you that. I used Map Crafter. And if you use Map Crafter, oops, wrong one, you can get your maximum velocity vectors, and you might need to set the scale a little bit longer so you can see those shorties. Okay, and that's your Map Crafter data right there. Now, what happens when we skip a number? That actually is a problem. It actually creates a little bug. And so, for example, if I am trying to review floodplain cross section number 7 with the reviewing tool, I'm not going to be able to do that because it thinks it's floodplain cross section number 6, and that data is actually missing. But what if I was I'm sorry, it's looking for a floodplain cross section number 7, and that data is missing. So every time you build a new floodplain cross section or you add more, you have to run the model again to get those results. So these are all in my run, and these two aren't in my run. So but this one's in my run, so I should be able to pick up data for it. But look, its number is 7. But look at its FID. Okay, its FID is also 7. But look at its row number. Its row number is 6. So I think what it's doing is I think it's looking for cross section number 7, but it should be looking for cross section number 6. So that's a little bug. We'll take care of that by the time you get this video. That may already be fixed. So if you get that error message, and again, if I look at my results tool and I look at you can see that it couldn't find that, okay? Now, what happens when you run the model? You get these 3 data files, right? You get highcross.out, crossq.out, and crossmax.out. And when you export the model, you get this as your DAT file. So there are only 6 of these, but my map is listing 7. So that's the bug. The map is looking for cross-section 7. There are no cross-section numbers like number 1 through n, so it does go off of this index. So this is cross-section 1, cross-section 2, cross-section 3, etc. And then that will correspond to control home, cross-section 1, wait, let me go down, cross-section 2, etc. Now, what do you get off of this report, highcross.out? You get cubic feet per second. That's the maximum discharge that crosses this line. There's your time, and that's your volume. Now, on this data table, there's 2 values. That is the average depth and the average velocity. Don't use those values unless you know exactly what you're doing and you're an advanced modeler, because these values, average depth and average velocity, are averaged over the whole cross section. So if your cross section is longer than your flow area, than your, like, say, your floodway or your flow area, then it's getting a lot of 0 velocities or 0 depths out there on the fringe. And that is going to skew your velocities low. So the only value you should be using from this really is the water surface elevation and the discharge, okay? You also get a file called crossq.out. And this would be taking every single grid element and giving you a discharge value for that specific grid element. Of course, it is still tied to that flow direction. And crossmax.out, just giving you some maximums. So this is an excellent way to look for bad data. So if I'm looking here and I'm seeing maximums that are not even close to my peak of my event, then either my cross section is really far away from my inflow nodes, or it's not right, and I might have invalid data for that cross section. Back to QGIS. One of the things that we do with the floodplain cross sections is we have connected them to the results tool, like I showed you. So if you click on one, if you're on the results tool, and this is pointing to the right file, let's get rid of these guys for now, and you click on one, hopefully I have data for that one. No, I'm not going to have data for that one. I'm only going to have data up through, yeah, I'll have data for this one. That would be the flow, the discharge crossing that line. I should have data for this one. Yep, there we go. That would be the flow crossing that line. And I should have data for some of these in here. What is it? What number is that? Number 5. And then, of course, number 7 didn't have any data because it was referencing the wrong cross section. And then I didn't export number 8 and 9. I made those during the video, so they haven't been exported yet. So I'd have to export and run the simulation again to get those. So for now, if you have that issue where these values aren't aligned to these, or these values right here aren't the same as these values right here, let me know, because you can definitely change those. You can't change those with an attribute table, but you can definitely change those with a SQL command in your geo package, and you can fix those, which is a really good idea to do that, because that FID needs to be, right now, that FID needs to be in order from 1 to n number of cross sections to match your DAT file and to match your output file. So I think that's enough information for the new floodplain cross section methods for FLO-2D Gila 2.0.